Hello, math students. Welcome back to our module entitled Linear Equations. And this is lesson 23, the defining equation of a line. The goal for today is, we will practice graphing lines to see if they represent the same line. The question that I want you to think about during this lesson is, can two different equations represent the same line? Why? Things to remember. It's all in the graph. Okay, so the first thing that it says is we're supposed to graph negative 16x plus 12y equals 33 and negative 4x plus 3y equals 8. So that's the first thing that we have to graph. And so for the first thing that we want to do is we need to either change them into slope-intercept form, which has become very easy for us, or we can use the substitution rule for zeros. And so I want to try the substitution rule for zeros because I have a tendency to not want to do the other one very often, and so that's going to help us figure out what we're looking for. So when x is 0, we find the y-intercept. So if I take negative 16 times 0 plus 12y equals 33, then I have negative 16 times 0 is 0, so I have 0 plus 12y equals 33. And then I have 12y equals 33. And then I'm going to divide both sides by 12, and I get y equals, and then 12 goes into 33, 2, and then 33 minus 24 is what it would be, right? Because 2 times 12 is 24. So now we're going to do 33 minus 24, and that gives us 9. So that would be 9/12, which simplifies to y equals 2 and 3/4. So now my ordered pair would be 0 and 2 and 3/4. Okay, so now I know where the y-intercept would be. And so I go 0 up 2 and 3/4. So there's 1, 2, and 3/4 is almost a 3. So that's where my point is, right? So that's how we have that point. And then what we need to do is figure out what would happen when y is 0, because that will give us our other axis intercept, which would be the x-intercept. So let's go ahead and try that one. So it would be negative 16x plus 12 times 0 equals 33. And so we have negative 16x plus 0 equals 33. I'm sorry for my throat, it's really bad. Negative 16x equals 33. Divide by a negative 16, divide by a negative 16, so x equals, and 16 times 2 is 32, so it would be negative 2 and 1/16 is your x now. So now we have our x is negative 2 and 1/16, comma 0 for the y. And so that means we have to go to the left, 2 and 1/16 and 0. So that would be about here. And now we have the 2 points that we need to make a line, because remember, all you need is 2 different points to make a line. And so now we have this guy as that line. Okay, so that's that side. Okay. Now we're going to graph this guy by doing the same thing. So we have negative 4 times 0 plus 3y equals 8. So again, we're figuring out where x would be 0, so that's the y-intercept. So this would be 0 plus 3y equals 8. 3y equals 8. Divide both sides by 3. So y equals 3 goes into 8 2 times, which is 6. 8 minus 6 is 2, so it's 2/3. So the y equals 2 and 2/3. So our ordered pair would be 0, 2 and 2/3. Okay, so when x is 0, y is 2 and 2/3. So we go up 2 and then 2/3. If that's 3/4, 2/3 is slightly below it. So I might have to use a darker color so you can actually see it. So slightly below it would be that guy. Okay, and now we're going to do the same thing for when the y is 0. So we have negative 4x plus 3 times 0 equals 8. So we have negative 4x plus 0 equals 8. So we have negative 4x equals 8. Divide both sides by negative 4, and you get x equals negative 2. So now we have negative 2 comma 0. So that's where this one collides. So negative 2 is exactly here. And then we have 0. And so they look very, very similar, right? Very, very similar, but not exactly the same. If I can get it. Yeah, so that's crazy. Look at it. It's hard to see on if I'm really zoomed out. So let's see if I can get any bigger. But there's your two lines. They are almost identical. Check it out. That's pretty crazy. Look at the space in between the two lines. Okay, so almost identical. That's pretty cool. Okay, so we graphed both lines by finding the x-intercept and the y-intercept so that we could graph them. And so that's what they look like. All right, so now that we've seen them on the graph, now it's saying compare them based on their parts. And so if we're looking at this, we have the a in this one would be negative 16, right? The a on this one would be negative 4. The b on this one is 12, and the b on this one is 3. And then the c on this one is 33, and the c on this one is 8. Okay, so now it says divide a by a, b by b, c by c. If they have the same answer, then they must be the same line. Okay, so a divided by a, well, negative 16 divided by a negative 4 is 4, right? 12 divided by 3 is 4. And 33 divided by 8 is 4 and 1/8. So that is why, if you look at it, they're so close, because this one was a 4, this one was a 4, and this one was a 4 and 1/8. So they are slightly apart because of the C value right there. If this had been a 32, then we probably would have had the exact same line. Okay, so that's kind of cool. And this is what you're going to have to do in class today, is you're supposed to figure out if you can have two different equations that represent the exact same line. And so we're noticing right here that if we change this slightly, instead of it being 33, if we had changed it to a 32, so the C value up here was 32, then you take 32 divided by 8 and you do get 4. And so if this was 4, this was 4, and this was 4, when we graphed it, it would have sat right on top of each other and it would have been the same line. Okay, so going back to our goal, today we will practice graphing lines to see if we represent the same line, and we did it by finding our intercepts, our y-intercept and our x-intercept, which was kind of fun practice. Can two different equations represent the same line? Why? And the answer that we discovered with this is yes, two different equations can represent the same line if, when you divide your A's by A's, B's by B's, C's by C's, and you get the same answer. Okay? So if this equation right here had been a 32, like I said, then these two lines would be sitting on top of each other. So yes, is it possible to have two different equations that represent the same line? And the answer would be yes, as long as when you divide the A values by the A values, the B values by the B values, the C values by the C values, and you get the same answer in each one, then you would have the same line. And basically what it's proving to us is that these right here are just this multiplied by 4 if this was a 32. So if I cross this out and make this a 32, negative 4 times 4 is negative 16. 3 times 4 is 12. 8 times 4 is 32. So basically you just took this line and you multiplied it, all of the terms, by 4, and so it truly is the exact same line. Okay? So that's what you get to do in class with your practice when we get to that. Okay? All right, I think that's all I have for you today. Talk to you soon. Bye.